right,
So no matter how the ship moves?
in principle,
Yeah.
you're
So,
hearing me,
I
but
have one of those
we have Miss
handheld
Rose in the
drummers
background.
for my camera, but I
So,
don't have it with me.
as you can see, we have this thing set up with a hydrogen tube, and it has this really kind of cool color here, huh? So, what happens is that because it's an elemental gas, it has this fingerprint that you see here. Now we're looking at hydrogen, although this thing doesn't have the whole digital spectral fingerprint, but we can talk about that another time.
Okay, let's just.
It turns out that when people started doing this sort of thing, and Newton wrote his papers about splitting up light into different colors, that we had what I would call the age of measurement in the late 1800s. And people started turning these devices on all manner of things, and they started using this prism here. And that is, in fact, first of all, they started identifying separate elements. They looked for those fingerprints. And in fact, this is how helium was discovered, because helium doesn't exist in the atmosphere. And any helium that might come out of the ground will go out into space. And so when they started looking at the spectral signatures of the sun, they saw this unknown, and they couldn't figure out what it was, and they called it helium for Helios. Now, if you look here, this is pretty nifty. Now, you can kind of see that there's some colors there. In fact, there are lines, and you can't see them in this view because the camera won't focus on it. But we've set up this prism so we can see that there, and what we can do then is we can shift this guy in its place, and I doubt we can see something. I'm going to pause this for a minute. Well, now we can also see how I've got this finder scope in here, and you can see the possibility of the lines, and then this eyepiece was put in, and you can't really tell, but there's these little cat's hairs. I used to call them cat whiskers and crosshairs. So this is really, really cool, because you can see, and it won't focus, but you can actually see that it divides it into lines. So I'm trying to, so you can see I've got the red line in the exact center. All right, so now once I've got that centered there and use the cat whiskers, I tighten up this screw right here. So now the thing can't move. And notice this thing is in degrees, and at straight on, well, of course, it doesn't say 180 degrees there because you see the indicator is a little bit off to the left. And then I go ahead and I read off a measurement, and there's this extra set of numbers there that's called a vernier. And so with the vernier, now that I've got it set up, maybe we'll use this little magnifying glass. And let's see if we can take a measurement here. So what I see is 129 and 30, and now I have to go along on these little lines, and I have to see which one of them matches up to one of the, of course the light is going to get right in the way just at the right time. And let's see if I can adjust this. There we go. So I'm going to call it at the 5 line there. Neat. So that means I have 129 and 30 minutes plus another 5 minutes. What happens is the degrees are divided in half because our vernier goes from 0 to 30 minutes instead of 0 to 60. So that's why we divide the degrees into half. So halfway is 30, and then we add the vernier measurement. Okay, and then what we do is we take this data here, and notice that both Dr. Cacciatorina and I have taken turns, and this is great. This is good experimental technique because we're trying to see if our measurements are close to the same. So I estimated an error of plus or minus 2/60ths of a degree, 2 minutes of arc, but you can also infer a plus minus because simply looking at the differences between myself and Dr. Kachatourian's measurements. Very good.